All right, here we go. This is, what is it? 17A, right? So we're just going over some selected problems on 17A. All right, let's see. Here it is, number 10, square root of 32. So what we're going to do is we're going to simplify each of these first before we even think about subtracting them. Right? Okay, you can only subtract when you have like terms. You don't have any like terms here yet, do you? So you got to simplify everything, and then we'll see if we have any like terms to add or subtract. All right, so square root of 32. Well, this is what I'm thinking. I'm thinking 16 times 2, aren't you? All right. Now, 8 times 4 is 32, right? And you can take the square root of 4, but then 8, you got to simplify again. You could use that, but I think this is the easiest way to do it is 16 times 2. Does that pop in your head when you think of 32? It should. 16 times 2? Yeah, that should be something everybody knows. But we've talked about that before, right? So that should be something that pops in your head. What pops in your head when you think of 200? Yeah, I think of 100 times 2, because I can take the square root of 100, right? That's why I picked 100. All right. What about 72? What times what is 72? Yeah, you could go 9 times 8, right? But then you got to take 8 and break that down. 36 times 2. Does that pop in your head when you think of 72? Half of 72 is 36. It's nice when those numbers do pop in your head because, right, it's just a matter of knowing your times tables and all that kind of stuff. Well, anyway, yeah, you could have gone 9 times 8, right? And then taken 9, square root of 9 is 3, but then 8, you'd have to simplify that. 4 times 2, it's just like another extra step you have to do. I like 36 times 2 because you can do it all in one fell swoop. Would you agree? All right, so let's do this. We'll do a little bit in our head here, okay? So I'm not going to write down every little step. So I'm going to go the square root of 16 and the square root of 2. What's the square root of 16? It's 4, and then that 2 is still under the square root. You with me? Minus 3 times, what are we going to do here? Square root of 100. What's the square root of 100? It's 10. Now it's being multiplied by that 3. So the next step, that'll be a 30. See that? And then the 2 is still under a square root, so we keep it like that. Minus 9 times square root of 36, which is 6. And then that 2 is still under the square root. There we go. Let's clean this up just a little bit before we start adding like terms. So that still stays 4 square root of 2. This is what? 30 square root of 2. And this is 9 sixes? 54 square root of 2. Now we have like terms. Remember what I said up here? We couldn't add them up because we didn't have any like terms. But now we do. This is square root of 2. This is square root of 2. This is square root of 2. So now we can add them up. So let's do this. Let's go. This is easy, right? 4 minus 54. What's that? Negative 50, right? Negative 50 minus 30 is negative 80. And then what? Square root of 2. It's kind of like an x, isn't it? It's kind of like a variable just hanging around. Right? So we just add up the coefficients and we just write the like term square root of 2. And there it is. What do you think of that? Ooh, disappeared, didn't it? Because I have to change that. There. Now I can circle it. All right, we okay with that? Okay, that's not so bad. Let's try another one. 11. Alright. See what that looks like. Oh, okay. We're doing a little FOIL method here. So 7 minus the square root of 11, and then square root of 3 plus square root of 3. I'm looking at this problem. I mean, you think FOIL method right away, don't you? But you could also do this. You could add those two things together, couldn't you? Did you think about doing that? Let's try it. I don't know, it just popped in my head. What's 1 square root of 3 plus 1 square root of 3? It's 2. No, we're not multiplying, we're adding them. So it's like 1x plus 1x. What's 1x plus 1x? 2x. What's 1 square root of 3 plus 1 square root of 3? It's 2 square root of 3. If you wanted to, you could do it that way. That makes it a little easier, I think. But what are you going to have to do to this? You're going to have to distribute. Okay, so distribute it through here. So 2 square root of 3 times 7 is, it's just 14 square root of 3. Right? We just take the whole number and multiply it by the whole number and keep the variable. It's not a variable, I shouldn't say that. But the term, whatever you want to call it, okay, it's kind of acting like a variable though, isn't it? All right. right there. And then what do? Minus, and then what do we got here? I'm not going to multiply 2 by square root of 11. That stays 2. The square roots. That's it. You're right. Square root of 3 times the square root of 11, which is square root of 33. Is that the answer I read off? Yeah, that's probably what I read. All right. I think that's a nice, easy way to do it, don't you? If you wanted to, you could do a FOIL method on this, but then you'd have to add some like terms inside there somewhere. I kind of like, I mean, it's not like I taught you that, and it's not like, you know, just because I'm the teacher, I saw this magical way to do it. No, I just looked at it and said, oh yeah, they're like terms. I can add them up. That makes it kind of easy, and then I can just distribute that. It's not the only way to do it, but I think that's a good way to do it. Anything else from 1.7a? Which one? 9? Okay. 9. Negative 5 square root of 7 minus 7 square root of 63. Now we can't subtract those right now, can we? Because they're different terms. This is square root of 63, this is square root of 7. So what do you think we're going to have to do? Probably have to take that and simplify that somehow, right? And see if we can get any like terms. So I can't really do anything with that, so I'm just going to leave it like that. Put a minus 7 here. And let's think about 63. What times what is 63? 9 times 7. Good. So 9 times 7. Right? We did this earlier today. So I've got negative 5 square root of 7 minus 7 times. Now what are we going to have to do? We're taking the square root of 9, right? What is the square root of 9? It's just 3. That's multiplication right there. And then that 7's still inside that square root, so we still have square root of 7. Agree? All right. Let's bring this up to here. So I've got negative 5 square root of 7 minus, what can I do here? Yep, so that's 21 square root of 7. Now they're like terms, aren't they? This is square root of 7, this is square root of 7. It's just like saying negative 5x minus 21x. All right? So what do? You just add the coefficients. So that would be negative 26. And what's my term? It's just the square root of 7. And there it is. Good? So when you're adding stuff together, you can only add like terms. So, and they've rigged these things, obviously, didn't they? They didn't just pick some random number. They rigged it so it came out the square root of 7. All right? So that you could add the terms together. Anything else from A before we move on to B? B was a little tougher, you think? Well, some of it was, but... Number 3 on A? Okay, cube root. So number 3. It's the cube root of 32. Alright, now cube root's a little bit different. What I'm going to do is I'm going to take that 32, I'm going to break it down as far as I can take it, alright, into its prime numbers. So watch. Don't let me forget to put that cube root like I did the other day. Okay, so nobody points it out to me. Okay, so yeah, 16 times 2, 4 times 4. But let's take that even further. Let's go 2 times 2. That's a 4, right? Let's go another 2 times 2. Right? So there's 4 times 4, and then another 2. Right? Do you remember that? Do you remember 2 to the 5th is 32? That might be something that would be nice to remember. So 2 to the 5th is the same thing as 32. So I got 5 2's here. You with me? Now I'm trying to take the cube root, right? Now on the square root, for instance, if I had the square root of 32, let's say the square root of 32, what would I have done? I would have gone 16, right? Let's say 2 times 2 times 2 times 2 times 2, all right? What would I do? I would pair them up, wouldn't I? If I was taking the square root. But I'm not pairing them up this time. What am I doing? I'm grouping them by how many? By 3's, because I'm taking the, right? Because this is 2 cubed, isn't it? The cube root of 2 cubed is just what? If I have a 2 cubed inside, watch, if I have the cube root of 2 cubed, it's just a 2, isn't it? Because that cube root and that 3 right there, that cube, cancel each other out. It's just a 2. That's why I'm trying to group them by 3's here, because it's a cube root. What if it was a 4th root? What would I try to do? Group them by what? By 4's, okay? But it's a cube root, so this is the same thing as 2 cubed. What's the cube root of 2 cubed? It's what? It's just a 2. So this group of 3 2's comes out just to be 1, 2. Does that make sense? It's a little odd. So look, I got rid of those. Now, can I group any more of these in 3's? No, I can't. So the only thing I can do is write cube root of what? What's 2 times 2? It's 4. That's how I write the answer. Excuse me. Make sense? Okay. So when it's a cube root, you break it down into its primes. I think that's the easiest way to do it. You could have said 8 times 4 and then recognize that the cube root of 8 is a 2, but not everybody does recognize that. So I think the most basic way to do it is to break it down into its prime numbers, and then if it's a cube root, take all the numbers, if there's 3 of them, group them together, right? And go from there. All right? Okay. Let's move on to 17b. All right, do you have any on 17b that you want to do? Number 2? Okay. Wow, this is funky looking, isn't it? Okay, now this is a cube root of 3, isn't it? Plus 35 cube root of 81 minus, oops, let's make that minus a little bit better. And then it's 1 over the cube root of 24. Alright, so how in the world do we add these up? Now we're adding them up again, aren't we? So what do you need? You need like terms, correct? So let's see what we can do. Now that's already simplest form right there. What about the cube root of 81? We might be able to simplify that, right? So let's figure out what that is. I'll tell you what, let's just do that off to the side here. Cube root of 81. So I'm going to break it down into its primes. What times what is 81? 9 times 9, right? Okay, so 9 is what? 3 times 3? And then another 9 is another 3 times 3, right? We're taking the cube root. So how do we group them? In groups of 3's. It's a cube root. Okay, so what's the cube root of 3 cubed? No, it's not 3 square root of 3. It's 3 cube root of 3. Alright? So this right here that's in a circle came out to be a whole number 3. Right? So I got rid of that. Now this is still left inside there. It's a cube root, right? So it's a cube root of 3. So now let's write the stuff down. Now we didn't have to mess with the first one. Don't let me forget that little cube. Alright, and so what do we get for this? We got 3 cube root of 3. Agreed? Minus, let's do the same thing with 24. Cube root of 24. Well, let's do this off to the side. Cube root of 24. Let's break that down into its primes. What times what? 8 times 3. Okay, so 8 is 2 times 2 times 2 times what? 3. So now I'm doing the cube root, right? So I group them in 3's. So I happen to have 3 of these 2's right here. So 2 cubed, the cube root of 2 cubed is just 2. What am I left with? Cube root of 3. Alright, so it's 2 cube root of 3. Now the denominator is starting to look a little more like each other. Okay, they didn't really at the beginning, did they? But now they do, because they all have a cube root of 3 in it. This has 1 cube root of 3, this has 3, this has 2. So what do we have to do? We're adding fractions, aren't we? So what do we do when we add fractions? What's that? That's right, get the same denominator, get a common denominator. So look, forget the cube root of 3. What if I just had a denominator with 1, 3, and 2? What would your denominator be? Well, it would be 6, right? The denominator would be 6, right? You're getting a step ahead. Right, the denominator would be 6, wouldn't it? So it's going to be what? 6. It's not just a 6, though. Cube root of 3, right. My 3's sometimes don't look that great. That's good. That's our common denominator, isn't it? Now, Daniel, this is what you were talking about. So what'd you do to 1 to get to 6? Multiplied it by 6. So what do you do up here? Multiply that by 6 as well. So I've got negative 24 plus. What'd you do to 3 to get to 6? Multiplied it by 2. So what do you do to the top? Multiply that by 2. That gives you 70. You went 2 times what? 3 to get to 6, right? So you go 1 times 3. So it's minus 3. Let's see what we get. That's negative 27. 70 minus 27 is 43. Am I right? Check my math. 70 minus, what did I say? Minus 27. 70 minus 27. Yeah, that's right. It's 43, isn't it? 43 over 6 cube root of 3. I don't think they left the answer like that, though, did they? Right, because they want you to rationalize the denominator. Right, so let's do that now. Now, I could have done that right up here, but I would have had to do that 3 times. I figure I'll just add them up, keep the root at the bottom until the very end, and then just change it at the end. All right, so what do we do? Remember, this is 3 to the first, isn't it? Will that be enough? Because that will just give you 3 squared. Remember what I want inside the cube root. I want a 3 cubed inside the cube root. So this is already 3 to the first, so this is going to be 3 to the, no, not to the third, because if I made it 3 to the third, this would be 3 to the first, 3 to the third to be 3 to the fourth. So I only need this to be 3 to the second. Okay? Does that make sense? So, so now I do the same thing to the top, don't I? 3 to the second. All right, now let's see what we get. Look at the bottom now. I've got a 6. Now what's this? Cube root of 3, cube root of 3 squared. That's the same thing as the cube root of what? You don't need to write this part down, just doing this. So we're doing this part in our head. Of 3 cubed. What's the cube root of 3 cubed? It's just plain old 3, isn't it? So this times this root times this root just comes out to a plain old number 3. And that was the whole idea, wasn't it? The whole idea was to get rid of that root. And that's what we just did. We got rid of it. Now it's being multiplied, so we still have to figure out what our denominator is. Now what do you get on top? You get 43 cube root. Now we're not going to leave it 3 squared. Let's just write it what? 9. Let's see what we can do here. We're almost done, aren't we? So it's 43. Whoops. It's 43 cube root of 9 over what? 18. Now, does anything go into 43 and 18? Nope. 43 is prime anyway, isn't it? So, is that the answer I read off to you? Just like that. Wow, that took some doing, didn't it? Yeah. But it made sense, though, right? I mean, most of it was pretty basic, right? We just changed, we reduced this root, and we simplified this root. We got them right here. Then we just went back to the old days, right? Found common denominator, found what our numerator was, right? So this stuff right in here was just middle school stuff, right? Elementary, right? Adding fractions. But then we went back to high school again, and now we had to rationalize the denominator, and we had to remember what to do. Okay, we did this yesterday. That was the first time we did that, was yesterday, so it might not be that familiar to you. Do you understand why we multiplied it by a cube root of 3 squared? Because we want it to be a 3 cubed, right? So I multiplied by 3 squared because this 3 to the first and this 3 to the second comes out to be 3 cubed. And then that'll cancel out. The cube root and the cube will cancel each other out, right? That'll go, that'll go. We're just left with a 3. Put it there, multiply by this 6. Don't forget about that 6 hanging around right there. Get an 18. There you go, nice and pretty. Good? Okay, let's try another one. We got a few minutes. All right, this is still section 17B. This is number 10. So, do I just multiply by a square root of x on the bottom and the top to get rid of the square root of x? No, I got to multiply it by its what? What was that fancy word we learned yesterday? The conjugate, right. So I'm going to put a parentheses around this, because when I multiply by the conjugate, I'm going to have to do a little FOIL method here. So what is the conjugate? What do we do to make the conjugate of this? Yeah, just make that a plus. That's all you do. Keep everything the same. You just make that minus into a plus. Now, if we do that to the bottom, though, we have to do that same thing to the top. And again, remember why we do that. We do that because it's just like multiplying by 1, isn't it? It's not because of a rule that says whatever you do to the bottom, you do to the top, because that's not a rule. All right? Don't think it is. Because oh, we are. I'm sorry. I didn't read the instructions. It says rationalize the numerator. What am I doing? I just kind of made an assumption, and that's not a good thing. All right, yeah, we're rationalizing the numerator on this one. My bad. They don't usually ask you that. This is like the only book that I've ever seen somebody ask you to rationalize the numerator. But that's what we are doing. So you got to get rid of the square root of x. This makes it even easier, doesn't it? All right, so really what do I have to do? It says multiply that by the square root of x, multiply that by the square root of x. That makes things really simple. So the square root of x times the square root of x is just what? Just plain old x. Now we multiply this. Got to distribute it though, don't we? So the square root of x times 2, or 2 square root of x, right? Just taking it times this, minus, what? This times this. Well, that's just an x. I'm done. Was that easy?
Yeah, I got something wrong. My bad.
Okay.
Yeah, I just made it.
Well, that wasn't so bad, was it? You think you're okay with these square root thingies? When did I say we were taking a quiz on this? Thursday? What did I say? Would you say we're not going to?
I said never.
Never. Nah, you want a chance to show off how much you know, don't you?
How long does that on like 2 or 7?
Yeah, Thursday. Well, I had planned to have that 1-7 review. I was going to have the same kind of problems, just different numbers, just so you had one more chance to practice it, but it looks like everything's down. Oh, it looks like I got my wireless back, but I don't know. I'll have to check my other one. Okay, that's it. Bye.